Next is a question on matching grid. We have some statements on the left which are to be connected to the corresponding statement which is associated to it. If IMN represents the integral sin raised to power mx cos raised to power nx dx, then it can be connected to any one of the following 6 integrals represented by I m minus 2n, I m plus 2n, I m n minus 2, I m n plus 2, I m minus 2n plus 2, and I m plus 2 n minus 2. Now each can be arrived at by integrating Imn equal to integral of sin raised to power mx cos raised to power nx dx by parts with suitable manipulation. Then match the following integrals with the corresponding results on the right hand column. First, Imn minus m minus 1 upon m plus n, I m minus 2n is equal to. Second, Imn minus n minus 1 m plus n, I of m into n minus 2 is equal to. Third, Imn minus m minus 1 upon n plus 1 into I m minus 2n plus 2 is equal to. And fourth, Imn minus n minus 1 upon m plus 1, I m plus 2 n minus 2 is equal to. Now the corresponding choices are A, sin raised to power m plus 1x cos raised to power n minus 1x upon m plus n. B, sin raised to power m plus 1 cos raised to power n minus 1 upon m plus 1. And C, minus sin raised to power m minus 1x cos raised to power n plus 1x cos x upon m plus n. And D, minus sin raised to power m minus 1 cos raised to power n plus 1 x upon n plus 1. These statements on the left are to be connected to the correct statement from the right and fill up the following grid. Consider Imn equal to integral sin raised to power mx cos raised to power nx dx equal to minus times cos raised to power nx into minus sin x into sin raised to power m minus 1x. What we have done is, we have split sin raised to power mx into 2 parts, treating sin raised to power m minus 1x in first function and the rest as the second function. Integrating by parts, we get minus sin raised to power m minus 1x into cos raised to power m plus 1 upon n plus 1 plus m plus 1 into sin raised to power m minus 2 into cos x raised to power n plus 1 upon n plus 1, which simplifies to minus sin raised to power m minus 1 cos raised to power n plus 1 x upon n plus 1 plus m minus 1 sin raised to power m minus 1 m minus 2x into cos raised to power n plus 2x, which shows Imn minus m minus 1 upon n plus 1 I m minus 2 n plus 2 is equal to minus sin raised to power m minus 1x cos raised to power n plus 1x upon n plus 1, which shows clearly third is matching to D part. But this can be continued to prove the first as well. If we simplify, that is minus sin raised to power m minus 1 x cos raised to power n plus 1 x upon n plus 1 minus plus m minus 1 upon n plus 1 integral of sine raised to power m minus 2x cos raised to power nx into cos square is replaced by 1 minus sine square x dx, which can be written as Imn equal to minus sine raised to power m minus 1x cos raised to power n plus 1x upon n plus 1 plus m minus 1 upon n plus 1 Im minus 2n minus Imn. Transferring the term containing Imn to the left hand side and clubbing the two together, we get 1 plus m minus 1 upon n plus 1 Imn minus sine raised to power m minus 1x cos raised to power n plus 1x upon n plus 1 plus m minus 1 upon n plus 1 times Im minus 2n, which shows Imn is equal to minus sine raised to power m minus 1x cos n plus 1 x upon m plus n minus m minus 1 upon m plus n Im minus 2n. Transferring Im minus 2 into n term to the left hand side, we get therefore Imn minus m minus 1 upon m plus n I of m minus 2n equal to minus sine raised to power m minus 1x into cos raised to power n plus 1x upon m plus n, which shows 1 is connected to option C. Now consider again Imn as integral sine raised to power mx cos raised to power nx dx equal to cos raised to power n minus 1x into sine raised to power mx into cos x dx. What we have done is we have broken cos raised to power nx into two parts, cos raised to power n minus 1x into cos x, and treating cos raised to power n minus 1x as the first function and the remainder as the second function, and integrating by parts, we get cos raised to power n minus 1x into sine raised to power m plus 1x upon m plus 1 minus n minus 1 into cos raised to power n minus 2x into minus sine x to sine raised to power m plus 1 x upon m plus 1 dx, which simplifies to sine raised to power m plus 1 x cos raised to power n minus 1 x upon m plus 1 plus n minus 1 upon m plus 1 integral sine raised to power m plus 2x cos raised to power n minus 2x dx, which when transformed to Imn minus n minus 1 upon m plus 1 I m plus 2n minus 2 equal to sine raised to power m plus 1x cos raised to power n minus 1 upon m plus 1, which shows that fourth is matched to B.